everyone. I'm Greg Jones for Engine Builder, and my guest today is none other than Billy Godbold. You'll probably know Billy from his time with Cams. He's spent 25 plus years with Comp Performance Group, and nearly 20 of those years leading the company's Valvetrain Engineering Group. And if you get camshafts from Cams, you most certainly know Billy. Even if you don't get camshafts from Cams, there's no doubt you know Billy from the industry. And Billy, thanks for joining us today.
It's very good to be here.
Hopefully I got some of that right. Didn't mess any of that info up.
No, I mean, you have to understand that I just turned 50, and I'm slowly but surely getting to kind of grasp what my boss was going through his mind at the time. You know, I was 24 years old when I started at Comp. I was 25 years old when I basically became over the Camshaft development group. And, you know, it's kind of like handing the keys to a 63 Corvette to your teenage son and saying, hey, you can take this to prom, but don't wreck it. You know, so, you know, at the time we were dealing with almost all of the major NASCAR teams, and sort of just threw me in. It gave me what he called the Naval swim test, where you just throw the guys into this pool, and if they swim out the other side, you check the box that says that they can swim. So
right.
Cool. It was an amazing time, and I've enjoyed every day since. And honestly, in many ways, today is probably the most exciting time I've ever been in this industry.
Well, that's great to hear. And yeah, there's no question that 2020 has been kind of an insane year for a number of reasons. And that's kind of what I wanted to ask you first, just, you know, how have things been going this year for you and your team and Cams in general? Yeah.
Well, I mean, like you mentioned, 2020 is very odd. You know, it could be one of those years where we don't have a single customer that didn't have a record year. Unfortunately, those records aren't all records high. You know, if you were building for certain top fuel teams that didn't race, you know, that could be a really hard year, especially if you're a professional engine builder, you're working in a very small genre, a very small number of applications. If those applications aren't on the track, man, my heart goes out to those guys. It's been extremely hard to some customers. On the other side, you know, if you're building parts for street cars, for performance builds, and somebody's locked up at home and the kids are going crazy and everything like that, you know, being that close to your project in the garage makes it super tempting to go zoom from the garage, right?
Absolutely.
If you're zooming from the garage, you're like, that thing really could use another camshaft in it, or, you know, a supercharger, or, you know, a new transmission or whatever like that. So, you know, we, I guess like everyone in the industry, around March, we prepared for the apocalypse. We're shocked by the number of orders, retooled, regrouped, tried to figure out what we could do. You know, and it's been, like you said, it's been a good year in many ways, but it's been you know, a very chaotic year for many people. People like me, we don't, you know, we got kind of this Peter Pan thing going on. We don't want to grow up and get real jobs. And right now, real jobs don't look any better than our jobs. So, you know, we're going to get in here and really enjoy this industry. This is our passion. Nobody went into motorsports thinking, oh my goodness, I'm going to do this because I want to get rich. You know, they went into motorsports saying, man, I love this. I want to do this as bad as I've ever wanted to do anything. And if I can keep a roof over my head, darn it, you know, my family fed, I'm going to do this to the best of my ability. Now, some people have been very successful with that deal. You know, Scooter told a story about whether to send out a cam one time to one of the major NASCAR players. And he was like, you know, trying to figure out whether he just send it for free or send it COD check okay. And he knew if he sent it COD check okay, there was a real chance the check would bounce. And he didn't want to have to pay his bank for the bounce check fee.
Right.
It's cheaper just to send him the camshaft, you know. And the guy we're talking about is a multimillionaire now, you know what I mean, in the hundreds of millions of dollars. So people have been very successful following their passion over time. You know, plenty of us like me just have gotten to have a amazing career and gotten to do things they never imagined. And so it's good for a lot of people.
Absolutely. No, that's well said. And certainly one of the things that's come out of all this is these Zoom calls. And I was curious if it sounds like you've like the rest of us been doing them and kind of forced to use Zoom as a tool. But has it been something that's welcomed? Has it kind of changed the way you do business with customers and your team to the better, or not?
Well, it's interesting because, we learn how much we communicate with our eyes and our face. And certainly having to wear a mask when you visit customers, you lose some of the humanity of it. You lose some communication, so somehow, like a Zoom call without a mask might be better than in person with a mask.
Really, I wanted to talk a little bit about your role these days, and I know you're in charge of a fairly large team, and you got a number of different responsibilities. So I was wondering if you could just maybe walk us through what a typical day looks like for you.
Well, it's interesting because as the structure of the company's changed over the years. It's kind of funny that since for, like you said, for about 20 years I've been over the Valvetrain Group. Honestly, I like that title. I think that I don't want to be demoted or promoted, because you start promoted, whatever it is, it's just not a good thing. Somebody needs to feel ownership of a camshaft when it goes in the box. My position's really unique because when you hear about Billy Godbold, a lot of what you hear about me isn't totally me. Well, it certainly isn't. No, it's not even mostly me. There's a team of engineers here that when they do good things, Billy gets the credit. There's a bunch of guys in the sales. When they help somebody get the right camshaft, Billy gets the credit. When the guys at the grinders do a great job with, the guy pulling the camshaft core picks the right core, Billy gets the credit. When the guys grinding the cam do a great job, Billy gets credit. QC, same thing, So comp cams is hundreds of people. And a lot of times what goes right gets gets put to my account. Now, the only thing that makes that halfway fair is when anything goes wrong, I also get total blame. So, but that's kind of a neat deal. No, so my normal deal, my first responsibility is to make sure that our cam designs are the best cam designs of anybody in the world. That we have, let me see, since I'm on my PC, I can go over here and find out how many lobes we have today. So I look at the lobe list, individual lobe design. So this is just tappet motion files. We're somewhere in the 50 to 100,000 range right now. My computer's locked up trying to calculate all of them.
Yeah.
That's just the tappet motion. So, you multiply for each different journal size, for different applications, things like that. You're talking about over 500,000 unique lobe profiles that we grind.
Yeah.
So that's a huge number. But we're always looking for what's the next. Like yesterday, I probably added 10 new profiles to that 50,000. So if it was 50,000 yesterday, it's 50,005 today. Over 20 years, that certainly adds up. Some days are a lot more than that because you're adding a family of lobes. So if you look at that, I'll talk to a few customers. The next responsibility other than designing the camshafts is my customer is probably our sales group. Like people call me asking for a camshaft. That's not really what I do well. What my job is when someone calls up someone in the tech office or the engine builder sales room, and they aren't 100% confident of what they should do.
Yeah.
My door is always open. They can come into my office. They go, Billy, this, and this, or send me an email, this, and this. What would you do? How would you approach this problem? And sometimes I'll get on the phone with the customer directly. But if I get on the phone with the customer directly, I always want to have one of those sales guys with me because I want them listening to how I would approach the problem. Some people know this. My background's in nuclear physics. So, it's in just physics, but I worked with the nuclear physics group at Florida State. So I have a master's in nuclear physics and my undergraduate's in physics. Took a lot of engineering courses over the summer, worked in machine shops over the summer. I'm a farm boy from Mississippi, so I'm not totally inept with my hands. But where I shine compared to most people that you would in our industry is how the camshaft is like the conductor of a symphony, how the camshaft's like a football coach for an NFL team or a good college team. You know, college football is really interesting because there's always some strengths and weaknesses, right? And when you build an engine, it's kind of like that. Hey, maybe I don't have the best tight end in the world, but I've got 4 good receivers. Well, hey, let's go 4 wide all the time. You know what I mean?
Right.
The camshaft's called the harder mind of a performance engine because each valve event dictates the wave tuning and it interacts how the exhaust system and intake system work together. So as I try to, other than design, what I'm trying to help our salesmen do is learn how to understand not just what engines respond to, but why does opening the exhaust earlier help it carry past peak power? You know, why does this certain overlap triangle work? So that's probably my second job. My third job is making sure that the cam shop has everything they need to produce the camshafts. Being over Valvetrain design means I'm also over all the specs, you know, what makes a good part, what makes a bad part. So I'm working hand in hand with both manufacturing and quality to make sure they have everything they could possibly need to do their job to the best, highest standard possible. Yeah. So that's gauging, you know, like surface profilometers. We have 4 AGCOL gauges in the back that cost roughly $250,000 each. So there's, you know, $1 million worth of cam doctors in the back. So that's a good little part of it. And then the next is the last thing I guess I do is sort of, you know, I'm really good at metallurgy. That's sort of material science is sort of my thing. I love that as much. I love combustion, you know, combustion sciences, airflow to a lesser extent, but material to a huge extent, you know. So I'll help them out with all kinds of projects on material stuff, whether it can be for a transmission input shaft, a connecting rod, a bolt, whatever it is. You know, what do these materials offer that other materials don't? And that can be outside of the Valvetrain, just the rocker arm retainers and things like that we make every day.
And like I said at the beginning, you know, clearly you have a lot of responsibilities, and there's a lot that goes into camshafts and Valvetrain in general. And you know, to my next question, it's a very complex topic and things that a lot of people don't quite understand, and they're always seeking more advice about it. And like you said, the camshaft and the Valvetrain is, you know, one of the more important aspects of the engine in general.
It's what ties everything else together. You know what I mean? That a lot of times the camshaft is the last thing you should pick. And it's funny how even people who are really, really good at engines don't get the subtleties of Valvetrain selection. Like they want to say, here's my bill for my engine. What's the perfect camshaft? And, you know, you take like something like I love in my spare time, I love road racing. You know, I think it's just the coolest thing, probably just because you get so much time on track and you can make so many mistakes and try to recover from it. Right. And it's just kind of stupid fun, right? But I was talking to a guy who's racing a NASA TT1, and he gave me all his engine spec. He goes, what's the perfect camshaft? And I'm like, it really depends on you as a driver, because, you know, a good driver or a really bad driver might want the same camshaft, where somebody in the middle might want a much smaller camshaft. And he's like, well, how could that possibly be? I said, okay, well, I'm a really bad driver. So I want a camshaft that's a little too big. And he goes, well, why in the world would you want that? I said, well, you know, if I'm coming in through a set of sharp 90s and I need to drop down into second, when I get on the gas, you know, on a, you know, way too much horsepower little car, you know, I don't want it to come around on me. I want it to be a little soggy, you know, right off at 3,500, because I will whip that thing around, you know, in a heartbeat, you know, and then go, why am I 4 off and through the cones and over here? Yeah. If you took the same deal and you gave somebody like Tony Stewart he'd want the same big cam that I want because he wants to keep those revs high and never go down into that 3,500 and stay up in that really good deal. Now, if you take somebody that's in between, he may be able to control the throttle better with that coming out of that corner in second gear.
Yeah.
Yet he's going to be over a broader range than a Tony Stewart because he's not going to make every shift perfect. So he needs a little broader torque curve. And, you know, it's funny. We used to do this like in 24-hour Le Mans. We had different camshafts on the same track for a short race and a long race. A sprint race would have a camshaft that had a narrower power band. And back before they had sequential transmissions and everything where they kept them in the thing when you actually had to shift it with a lever, we'd have a cam with a much broader power band for the 24-hour race because at 2 a.m, you just don't you can be Mario Andretti. You don't hit every shift just right. You just kind of, you know, I'm just going to over rev it here and I'm going to, you know, really I should come out of this corner in second, go 3/4 of the way down the track, shift into fourth, then go back into third. And that guy's just like, I'm just going to put it in third and run this whole.
Right.
Yeah.
So along those lines, Billy, you know, can you give us some examples in terms of aspects of the camshaft of how different lift, different duration, and lobe designs, you know, what do those things, you know, those different things offer?
Yeah.
In terms of performance?
Well, I think lift is probably the most misunderstood by people. You know, it's kind of like a magic thing where it really isn't. There's a simple ratio of lift to diameter of the valve that works great for just about anything. It used to be believed that about 20% lift to diameter was the OE number in the 50s. So if you go back and look at a small block Chevy that had a 2-inch valve-ish, it's going to have 400-ish lift. So a little over 20% lift to diameter. You know, and then it was figured out, hey, you know, valve jobs got better, ports got better. It's like, that needs to be more like 25%. So now same 2-inch valve. Now it's like 500 lift. And you can see that over time, that even got tweaked a little bit more. And the OE started to learn, no, it's probably, so if you're looking at, you know, last Cathedral Port LS 2-inch valve, it would have been like 520 lift. So they're like, okay, you know, about 27%. Really on the street with any decent head, about 30% lift to diameter is about right. But at the same time, in the race side, people got really good at the back cuts of the valves and the ports going up. So there we started to see things go, oh, well, you know, hey, look, 30 is good, but 35 or 40 is better. And about 10 years ago, 10 to 15 years ago, steep valve seats came really popular. And on a 2-valve engine, you don't see as much in 4-valve engines, but a 2-valve engine, you know, these 50+ degree seats, they like a lot of lift because if you imagine a cone of air coming down, it's coming straight at the valve when you make that seat more. So getting up toward the 45-50% range is about perfect. And, yeah, it's kind of funny back, you know, about 2010, I was at, maybe a little bit before that, I was at the one of the big shows in Cologne, Germany. And one of the F1 guys and I sat down between conferences and I go, hey, how much lift do you run? He goes, oh, I can't tell you that. It's top secret. I said, well, can you tell me how big your intake valve is? And he did. I said, okay, so you're running this much lift. And he just looked at me like I had stolen the recipe for Coca-Cola or the nuclear launch codes. You know what I mean? He was like just livid. And I'm like, it's simple. It's lift to diameter ratio. I know you guys are running steeper seats, you know, because you're running gazillion RPM. So I know you've got to run about 45 to 48% lift to diameter. So once you give me the thing, it's like, you know, okay, you tell me 33, it's like divide 33 by two and subtract 0.5 millimeter. And you're like, okay, yeah, there we go. You know, and clearly I was well within 1 millimeter and he was just kind of freaked out.
Yeah.
The whole deal is that so the first deal is just lift to diameter ratio. And that works whether it's a weed eater, you know, something like this little weed eater motor or a ship motor, you know, with the 6-inch valve. It's lift over diameter. Those guys will run like on a ship motor, instead of a 45-degree seat, they'll run, or a 50-degree seat, they'll run like a 35-degree seat. What that does is spread the air out so they don't have to run quite the same. They're still comfortable in that 25% range. You know what I mean? So a 6-inch valve doesn't need a 3 inches of lift, you know, because it's not going to be a 50-degree seat. But then, So first on lift is lift to diameter. Second on lift is you've got to figure out what valve spring you're going to use. Because most valve springs, you don't want to, I see people all the time buy a 650 lift spring and put it on a 550 lift cam. Now at 650 lift, that thing had 60 thousandths, that had 60 thousandths distance to bind. They put it on 550, now you're 160 to bind.
Yeah.
What people do not understand is running a spring well under its intended lift in most applications, applications that go over 3,000 or 4,000 RPM. Industrial engines, you get by with this, but on street engines that are going to be run near the rev limiter in any performance street, in any race engine, you need to be closer to bind. My wife was a Montessori teacher when we met. And right after I got married, I think I went over and watched her classroom. And you'd see this in Montessori, they all work at their own level and stuff. It's kind of a free range education deal. And I wondered how she kept control over it. And you'd see these boys get this work and they'd go get this, what they call their work to do, bring it back to their desk. And they'd be all fidgeting and moving and look like the gopher from Caddyshack. They're wiggling so much. And she would walk over behind them and just lay her hand ever so slightly on the shoulder of the child. And these little boys would just kind of calm down and get busy. About the same time, I'm looking at a video of a spring, and it's just a jiggling and wiggling as much as that gopher or that little boy were. It's going everywhere. As it get over to the close to the nose, the coils would get closer enough together that they just kind of dampen out, and then it was calm on the way back. And I'm like, oh my goodness, look how much more dampening. We try to run like dual springs with interference so that they rub on each other and dampen. But the real dampening, the real time zero for a valve spring is over the nose. And if you don't get that valve spring close to bind, you don't give it that chance to calm down. Now, if you get too close to bind, it'd be like her coming up with the bat behind the thing and just whacking the kid, which, that's either going to knock it out cold or cause a fight. So that's not good. You don't want to, there's really some magic in the distance to bind. Different springs like different distance to bind. But I've never seen a spring that wants to be 160 to bind. So a lot of these guys that you see. So what's funny is the two questions, if somebody was 3 questions would be, somebody wants to lift, like, okay, what are you doing? Because it's different whether you're going to be doing drag racing or you're going to be endurance racing or it's going to be street strip. Okay, you can look at the flow numbers of the heads, but you really don't have to because you can guess what the flow numbers of the head, knowing the valve diameter and knowing what the seat geometry is. This is a 45-degree seat or 50 degrees. Okay, it's a 50-degree seat. Okay, then the next question is going to be what valve spring are you going to be using? And we've got to select the valve spring to make sure it's happy on that distance to bind before we go any further in lift. Okay. He says he wants to race comp eliminator, and then I ask him what spring, and that spring isn't up to the task to get the lift where it was. Then we got to drop back, and call an audible and say, hey, that valve, either you don't need to race in that application, and have you considered a different class? Or, hey, we need to look at this different spring.
Gotcha. Okay. I know we've already discussed there's no, perfect camshaft out there, and it's all very dependent on what you're doing. But, I was curious if you could explain some of the differences between, a camshaft that you would run in a, boosted import application versus, an American V8 application, and then, what you'd see maybe in a performance diesel application. Is there differences you could explain?
Well, I mean, clearly one of the things is that Valvetrain is a system, for a few years I was over cam design, but I didn't have anything to do with rocker arms and valve springs and retainers and stuff like that. I just broke that stuff. Getting promoted to being over Valvetrain design, I thought was going to be this great thing, but it actually makes it where you're a lot more responsibility. If you look at most import designs, you'll see that they have very, very rigid valve trains. And because of that extreme rigidity, one, you don't have much shock absorber in the valve train. So you have to be careful about how you get it to start moving. But two, you have that extreme rigidity. So once you get it moving, you can really, really accelerate. So it wouldn't be odd at all to see something for a 4G63 or a K-Series Honda having 3 times higher acceleration rates than you would on something from a small block Chevy, or 6 or 8 times more acceleration than you'd see in something like a Duramax diesel with a, with the, long rocker arm fork deal, or one of the Power Stroke diesels.
Yeah.
So the first thing you have to understand is the system. What is the stiffness of the system? And, one of the ways we measure that is we'll get a checking spring with a solid lifter, go and check the lift with a spring that's only a couple of pounds over the nose, and then check it with the real spring that'll be hundreds of pounds over the nose, and look and see how much deflection there is. Measuring the deflection difference between lift with no load, loaded lift and unloaded lift, it's very simple. We want to know the deflection in pounds per inch.
Yeah.
I mean, so how many pounds to how many inches? So if you have, 10,000 pounds, if you have 100 pounds open and it moves 10 thousandths of an inch, you go, okay, well, I just move the decimal place over 2. So you're 10,000 pounds per inch stiffness, which is a really, really lousy stiffness. That's something like you'd expect with a long push rod, a long rocker, fork, maybe some diesel stuff. Or if you look at this overhead, it might be 50,000 pounds per inch. And somewhere in there between the small block Chevy, maybe 15,000 to 25,000 pounds per inch, 15, 20,000. So we've got to know what the stiffness is. And then the whole thing is as Valvetrain gets better and better, you get to start making some of the NASCAR stuff today would look very, very comparable to what some of the import 4-valve systems are in terms of stiffness.
Okay.
Very, very stiff and very, very light. And just because you have a push rod and a rocker arm, like a lot of people think that's a earlier design, but actually the push rod rocker arm, cam and block V8 came along well after overhead cams did. So it's not a less sophisticated design. It's just a more complex design that makes engines more compact, but it does make it where designing that system well is much more difficult. Yeah. But it certainly can be done with amazement. And I think you're seeing that with the new Ford 7.3 Godzilla, how, they were packaging a larger engine into a smaller package by using that architecture. But the Valvetrain, if you look at that, whether you look at a new, GM LT engine, or you look at the Ford Godzilla, or the Chrysler Apache Eagles, all of those Valvetrain systems are just, they're light years ahead of what you would see in a 1950s, 1960s style Valvetrain platform.
Yeah.
The other thing is they've done a tremendous job of, it used to be when you saw engine design, you could look at the engine design and tell who won in the draft, who had most authority in the drafting room. Like if you looked at a Hemi, you were 426 Hemi, you're like, yep, 100%. The port guy won here. Somebody was in charge of ports and somebody was in charge of Valvetrain, and the port guy got his way and the Valvetrain guy just had to put his stuff wherever he could fit it. And then you go look at something like a small block Ford with nice straight push rods everywhere and everything. You go, man, the Valvetrain guy won on this, and the port guy had to figure out how's he going to get his air in there. You know what I mean? And then you also had the guy who had to build the gasket, put the bolts in, right? And you're like, these 3 guys are fighting, and nobody's compromising for the other guys. And what you see today, when you look at a modern, LSLT, new Hemi, or any of the the Ford 7, whether it's the 5-liter Coyote motor or the 7.3, when you look at all these, you can see that mindset had to go away. That the guys working on clamping and the guys working on, it's like they made everybody go sit in a room, put gloves on like they were kids. And you guys fight this out until everybody agrees this is a good platform.
Right. Right.
And that's what you have to do on a modern engine. You can't have big compromises.
Yeah.
Emissions and it's a thing. It's a crazy thing. It's like the CAFE standards, the fuel efficiency standards, has given us these tremendous heads. The reason that you have a 300 CFM head on an American V8 today, if you go buy a pickup truck with a V8, it's got a 300 CFM head. That's half again more than it would have had in the 80s or 90s. And you're like, well, why do they have such great heads? Well, it's because they're trying to get rid of pumping losses at highway speeds. They're trying to get it where you don't create a lot of vacuum around the valve. So it's neat. It's like the stuff that we don't like is giving us these wonderful tools, because we got these great combustion chambers and we got these great ports, not just on the race side, but on the OE side. So it's kind of a cool time.
Right. No, absolutely. Modern day engines are amazing.
Yeah.
Billy, I was curious if there's kind of a most common, camshaft style and lifter style that you're seeing being used today, in terms of what guys are preferring, or what you guys are putting out there more so than something else.
I think we see we see a lot more people modifying the cam and block engines than the overhead cam engines. Some of it I think is just fear based. Like, hey, everybody, you can go on any YouTube channel and find 50 people changing a camshaft on an LS and 20 people changing the cam on a Hemi. But I think they're a little bit afraid of the Coyote motor. That's probably our fault. There's some things about changing the cams on a Coyote that's much easier. You just can't let the chains get loose, right? Or you want to have them take the whole motor out and try to degree the camshafts. You got to figure out tools to hold the chains in place, and you got to know what you're doing or you can get in trouble. But I think the other thing is probably just the cost. If you have to buy, one $400 cam or four $250 cams, that, the four $250 cams put you up, the cost to take your Mustang to a tuner and change camshafts, I would imagine is 2 to 3 times higher than it is to take your Camaro in and change the camshafts.
Yeah.
And so that makes that's a little barrier, but honestly, I don't know. I wouldn't be surprised if that goes away over time, that people get where they're more. We probably see more domestic than anything else, but that's just because of who we are. People assume, when you grew up in NASCAR and in HRA, your clientele knows you, where people who are like working on a motocross deal wouldn't necessarily call comp cams. They'd call somebody that's involved in motocross. But it's kind of funny because, like we had a NASCAR team get involved in motocross, and the first thing we did is help them with camshafts, right? So, it's not that you can't, it's that's just not where your customer base and where your sales base is driving.
Sure.
You don't have, to have a good sales of a product, you really need a good sales team, marketing team, customer base working together to make that product successful. And it's not just making the best widget. You've got to have support for that widget.
Absolutely. Billy, we touched on performance diesels a second ago, and we've been doing a lot more content around performance diesels and that side of the market, and we hear a lot about alternate fire camshafts.
Yeah,
I was curious if you could explain that decision a little bit in terms of what differences that offers versus a regular cam.
Yeah, this used to be, if you go back to the 90s, like the firing order thing was the most magic thing in the world in pro stock. And then fast forward to, all the new engines coming out in NASCAR, they did all this firing order thing. John Lingenfelter for pro stock truck, he had, you can swap any two cylinders that are 360 out and firing. So every fourth one, you can swap. John Lingenfelter had every possible firing order, including the crazy bank stuff that he tried in pro stock truck. But there was all kinds of this stuff going on where people were trying firing orders. What really comes down to is with a cross-plane V8, you're stuck. You always got to fire on one pin at least one time consecutively. And you've always got to fire on one bank, neighboring cylinders consecutively at least one time. Now, you can do a lot worse than that, but you can't do any better than that. So if I'm going to have to hit one pin twice in a row, Do I want it to be the front pin, like a standard small block Chevy firing order, where the only thing you have to keep the crank from whipping around is the balancer? Or do you want it to be the last pin, where you think, well, Billy, all I got back there is a flywheel? Now, really, you've got the whole daggone vehicle. You honestly have the earth trying to dampen it, because the flywheel is connected to the transmission through either a clutch or a some sort of converter. That goes to a drive shaft, a differential out to the wheels. The wheels have tires on them. The tires go to the ground. So you have the planet Earth trying to dampen you. Believe it or not, the planet Earth is a better dampener than the balancer up front.
Yeah.
I know that's shocking, to the point that the balancer is actually part of Earth, So what you see with firing orders is, let's get that common pin that's going to get hit. Let's move it to the back. Then the next thing you see with the firing orders is, okay, you said two cylinders are going to fire next to each other on a bank. And you got to have that. Yes, you have to have that. Well, how did the small block firing order deal with that? Well, they put it back under the header at the back, as far away from the water pump as they could get it, and wondered why those cylinders had a hard time sealing. Most of the alternate firing orders move the paired cylinders up to the front near the water pump, because what happens with paired cylinders firing is they get hot in between. It distorts the bore, and that creates leak paths. So moving that to the front just gets it. There's more water flow closer to the water pump. I know, that's the most genius thing you've ever heard in your life, but it is in fact true. It's really hard to get as much water away from the pump as cool as you can get to the pump. So it just draws heat back away from that. So what engine builders see, due to that ring seal, they probably see about a 1% increase in performance. Maybe, two's a lot, but they say about 1%.
Yeah.
And the bearings, when you take an engine out with a revised firing order, you look at that front bearing, you'll see that front bearing's going to look a little better.
Yeah.
What's that mean to 99% of your customers? Well, it means that your 500 horsepower motor is 505 now, and your bearings that would have gone 500,000 miles will go, 600,000 miles. Is that a big deal? I mean, depends on just how hard. When it was just changing a couple of plug wires and spinning a little more on the camshaft, of course you do that every time. Now, if you have to get out there and cut a wiring harness and move things around and reprogram it, do you want to do that? Dude, I don't care. I'll sell you whatever firing order you want. You know what I mean? It's not a big deal.
Now, are the guys
want to see magic there? And it's not magic. It's very well understood at this point.
Yeah. Now, are the guys on the diesel side kind of doing it for the same exact reasons?
Exactly. There's no difference there. There's no difference there between gasoline, diesel, nitromethane.
Okay.
Because they do it in top fuel too. You know what I mean? Whether it's, they do it in diesels, they do it in nitromethane. And it's the thing is that, clearly on a 15,000 horsepower motor, 5%, 1 or 2% is a bigger deal. But,
Right.
150 extra, versus I made 5 extra,
Very good. Billy, obviously, you're dealing with a lot of customers who ask questions, and a lot of engine builders, as well as enthusiasts who are coming to you guys for advice on this stuff.
Mm-hmm.
Can you talk a little bit about what some of those common mistakes are that you see people making when they're selecting camshafts and valve train stuff?
Well, I think the most common mistake is goes back to what we talked about before, understanding that the camshaft is part of a package. Mm-hmm. So one of the things that I find, I don't know whether it's sad or just disheartening or exactly the right word to use for it, but you'll see somebody buy a ton of just amazing parts, wonderful parts. But it's like they never took the step back to figure out what their goals were. And the parts are all amazing, but they're a mix match. You've got a great, this is good for one application, that's good for another application. But the whole system together is like, is that what I really, there wasn't a great plan. So, good engines all have some great parts in them. but great engines started with a good plan. I've walked people through trying to build something for something else, and then they'll go and say, oh, I want to desert race this too. And you just want to slap your head and go, dude, this isn't like that. Performance engines are not Swiss Army knives.
Right.
They don't do everything well. They're precision tools. Do not use your micrometer to clamp down your weld on your welding table. You get shot for things like that. And that's the whole deal, is trying to figure out, what are your goals? What do you really want to achieve? And I don't think there's any bad goals. You know what I mean? You may go, I want to go 150 miles per hour in a jet boat. Okay, we can help you do that. George Poteet, I want to go 480 miles per hour at Bonneville. No problem. We can help you do that. Is the right camshaft to go 480 miles per hour at Bonneville the right cam to put into your diesel pickup? No, it's not even close. There's nothing about it. It's made out of steel. Yours is made out of steel. That's about, so I think really it's just, I think customers get excited, get caught by the flashiness of some parts, and takes a little bit away from the whole plan. Or they try to make their application do a little bit of everything. And when it does a little bit of everything, it doesn't do anything as well as it should.
Right. No, well said. Billy, along the same lines, I was wondering if you get some common questions when people are talking about this stuff with you. Maybe some common ones that you might want to address because you get them so often.
I think one of the things is that people get caught up in things like lobe separation. You brought up the diesel market. On the diesel market, really, I'm spending 99% of my time figuring out when the intake should close and when the exhaust should open. And then about 1% of the time trying to make sure that the valves don't crash into the piston without losing a whole bunch of compression. Like even when you put deep notches on the four corners of a diesel, you're dampening the swirl. Those little notches work like ratchets. They try to slow down the swirl in there. So, and this works whether it's a diesel truck for the street or whether it's a pro stock car. That really the two driving points are intake closing and exhaust opening. And then to a great extent, overlap, you're trying to figure it out, how not to interfere the valves and the pistons. Because there's this thing Einstein talked about the space-time continuum that I think it goes along the lines of two things can't occupy one space, one X, Y, and Z space at one time T. Yeah. And pistons and valves do not like trying to violate that whole deal. When you try to put a valve and a piston in the same spot at the same time, neither one of them wins. The valve gets bent, the piston top gets cracked, the engine gets blown up. It's just nasty. So, we haven't got a material that lets them bond very well.
Yeah.
So I think people go, well, a tight lobe separation makes peakier power and a wide lobe separation makes broader power. And they think that there's magic in the lobe separation. And literally when we're doing cam development, the last thing I look at is lobe separation. You know what I mean? And so that's just not something that's driving the boat. So I would just say from a layman who's starting in camshafts, they get all tied up on lobe separation and don't understand. And then the other thing that they don't understand and I sort of touched on it in the same deal, is how important combustion efficiency is. And you can't mess up your piston to try to get the camshaft in. Remember we talked about how the camshaft was the coach or the conductor?
Yeah.
I want to put the guy who's designing the piston to tell me what he wants for valve pockets to fit, and he's going to tell me, okay, well, I want no valve pockets. I'm like, okay, can you give me a little? Well, I can give you a little without messing up much. So there really needs to be, just like that deal with the port and push rod, there needs to be that deal with the camshaft and the valve seat, the valve reliefs. You don't want these huge valve reliefs because they do nothing but make your combustion chamber slow.
Gotcha. Okay.
I think that's probably something about understanding lobe separation and understanding the interaction between valve clearance and overlap. I think that's probably the most misunderstood and the things that people just get totally off the reservation on.
Yeah. Very good. Billy, one of my final questions here. Again, just touching on your years of experience and being in the industry for about 25 years now. I'm sure you've witnessed significant changes in engine development. I was curious if you could talk a little bit about, what you've seen that's kind of changed the same because it's, been so effective, or sorry, remained the same because it's been so effective versus, what some of those biggest improvements have been, in engines today.
That's a great question. I think what stayed the same is engines are fundamentally air pumps. So in the fundamental side of it, the goal of any engine to make most power is to get as much air in and out of it as it can. And I think that we go from time to time that we lose sight of that. We expect something magic. But I think that's the thing is we forget the fundamental, the thing that we have to keep, the thing that we know, but we forget and we keep coming back to is the fundamental, it's an air pump. And likewise, the thing that we keep getting better at, the thing that's been the whole thing is every year we where we make better air pumps that have better combustion efficiency.
Right.
My son is I have 3 kids. One of my boys is my youngest son is at Georgia Tech right now working on his PhD, and he's studying diesel combustion. And to watch him working on his PhD, and they're doing what's called ducted injection, where you have an injector that flows through a small duct, and showing about how that improves combustion, how that releases more energy, how that creates less soot, how that requires no after treatment and things like that.
Okay.
Watching his research and seeing how much we have to learn yet about extracting as much possible energy out of every drop of fuel is the coolest thing ever. And you say, okay, it's like on the Chrysler Hemi, it's like, hey, Hemis are inherently bad on combustion. You can't put the spark plug. They go, okay, we'll put 2 plugs in it. It's like, oh, well, that actually works. Okay. It's like, there's things that it's just crazy to see how quickly we're understanding combustion efficiency is so important. In Mercedes and F1, they crossed the 50% threshold with energy extraction. The BTUs in the fuel versus the power to the crankshaft, they crossed 50%.
Yeah.
And to do that in such a small platform, that's only been done before in things like ship motors that go like 600 RPM and that you can ride the piston like an elevator. So you can imagine something that's going 15,000 RPM with a little bitty piston, and it's still achieving that type of thermal efficiency. Those type things, that would be sort of like, when people thought you couldn't go faster than the speed of sound, that 50% number, that was sort of the thing, you can't do it.
Yeah.
And now your OE engineers could say, well, you can do it, but you can't do it and pass NOx. Well, someday somebody's probably going to show them, hey, you actually can cross 50% and have NOx. So I guess that's what I was saying. When we started, I said something about this being the most exciting time that I've ever seen in the industry. I think we fail to realize that while hybridization between electrical and gasoline engines, or diesel engines, while that shows amazing promise, that I don't believe the diesel engine or the gasoline engine is anywhere close to dead. I think you'll see whether it's, for air travel, jet turbines, for diesel, for heavy diesels and things like that, the amount of energy we're able to extract from fuel today is just would blow anybody's mind. And I think we've sort of forgotten that these things are super cool.
Billy, I think that was really well said. A great way to wrap this up. Talking about how much more we still have to learn and still can get out of today's gas and diesel engines. And I really want to thank you for your time today, and let me know if there's anything else you wanted to add.
Well, no, we just greatly appreciate it. Back to the whole thing about we don't want to grow up and get real jobs. We enjoy doing this so much. Any way that we can be help to our industry, we want to do it. Know that everybody at Comp Camps joins me in saying that. We love that we get to do this. We want to help your readers, your viewers, your audience. Your people are our people. You know what I mean? We are a family, and even when people don't, use Comp Camps, that's not the end of the world. We want people to enjoy this industry, to enjoy this sport, enjoy this way of spending their money. And so anything that we can do to help you be successful, to help your readers be successful, to help people watching this podcast, this seminar be successful. We want to just help grow this industry as strong as it possibly can be. At the end of the day, we're going to fight like Hades to get our fair share of the pie and maybe a little bit of somebody else's.
Hey, absolutely. I can't knock you for that. And again, Billy, I really appreciate you being here, joining me on behalf of Comp Cams, and thanks again for your time.
All right. Thank you. Have a great day.
All right. Thanks, Billy. You too.